is from Canberra, but he has spent the last few years in the States. He will tell you all about his interesting journey over there and what he knows. But what is cool is you're going to find out a lot about what's involved in running a platform, keeping a service up and running. Grant went to the States and worked for Brian Harry, worked for his team, Visual Studio Online it's called now. It was called tfspreview.com. And Brian had Grant managing all the internal servers for Microsoft's adoption of TFS internally. And they had some monumentally large clients. Basically DevDiv is running on TFS internally, and that's a lot of people. And he had to work out how to do all that. Then, when he came back to Australia, because his wife Emma had a little one, and that gets in the way of some things, Brian gave Grant a call, and Brian is one that is a believer in teams and having people working with him in his building in Raleigh, North Carolina. And I believe he only has 5 people working for him that are remote, and Grant is one of those. So you really have to be a trusted guy to get that privilege with Brian, and I think that's a real feather in his cap, and I think he's going to give us some really nice stories. So up you come.
Thanks, Adam. We all good on the video? Alrighty. So thanks for the introduction, Adam. I started at Microsoft in 2008, and at that point in time, TFS, Visual Studio Online and TFS in the cloud was it was an idea that people had, but it was kind of too early to kind of make it real, because TFS was as an architecture, it was evolving. We only supported 32-bit operating systems, and we only supported one database server, and sort of over the TFS kind of releases, we slowly added more things in to finally get to the point where we could make it an online service. And then kind of in the meantime, Windows Azure came along, and we're like, right, that's the platform that we're going to build on top of. So if you need to contact me, just do a search for Grant H. You can email me, you can go along to my blog. I haven't blogged there recently, but when I was over in Seattle and Redmond, I was blogging quite regularly, because I'd have my days were just full of diagnosing problems and coming up with insights and things like that. So lots of kind of older articles there. As kind of Adam mentioned, all these little kind of markers these are where my team members live and work. And so obviously we've got the little blue-green marker down there in Australia. I work in Canberra. Now I kind of split my days between working from home and working from the office. One of the things about working remotely is that you are remote, so you can't just kind of, the people that you work with, you can't have kind of a face-to-face meeting with them. And so what I tend to do is sort of do a couple of days a week. I'll actually go into the office to meet other Microsoft people, not necessarily on my team, but we'll have lunch together, and that's kind of the real person sort of contact which you need when you're working remotely. The other 2 remote people is we've got Ladislow in Europe, and he started off as a escalation engineer for when people call customer support and they have a TFS issue. And so he's got deep knowledge of the product, and so Brian said, right, I want Ladislow on my team as well, because if we're going to have, if we're going to run a successful service, we need people to understand, how to kind of operate the service. The other guy we've got a guy called Lucky in India, and he was an escalation engineer as well. And so I've got Ladislow, Lucky, myself. That's 3 different time zones, and then we've got half the TFS team, or what's now called the Visual Studio Online team, is over here in North Carolina, in Raleigh, and that's where Brian lives, and with half the team. And then the other half of the team is over here in Redmond with kind of the rest of Microsoft. Can anybody tell me what this red little marker on the right here might be? It's a data center. Any idea where it is? Chicago. Good guess. So that's the Chicago data center, or what Azure call the North Central US kind of region, and that's currently where TFS Online, or Visual Studio Online, is hosted. Now we do have plans to go to multiple Azure regions. We're just not there yet, but that's where pretty much everything I do every day is talking to servers, over in Chicago. So you can ask me about latency, and I'll tell you, exact numbers and routes and all that sort of stuff. Question, Adam?
Yeah, there's one guy that I can think of, Martin Woodward, the guy that created TFS for Eclipse.
Yep. So Martin Woodward is up here in Northern Ireland, which is not actually Ireland, it's the UK. There's another guy called Philip Kelly, who's a dev on the version control team. He's over here in Pittsburgh. And there's another guy, Ed Thompson, who's, I'm not sure where he is, but he's in the US somewhere, and he does a lot of the Git integration stuff. So there's really only a handful of sort of remote people that work for Brian, and all of them have previously worked, in an office, with the rest of the team. So we kind of understand how the processes work and the people, and got those relationships and connections. So it's pretty interesting. And the beauty of my particular team, having them spread across 5 different time zones, is we can actually do around the world coverage without people having to be on call, in the middle of the night and things like that. And I'll talk about how that works a little bit more later.
Speaking of coverage,
Yep.
who broke it today?
Sorry, speaking of coverage, who broke it today? It wasn't me. We had a deployment this morning, and there were some issues, as you saw on our server status blog. Were you guys kind of impacted here?
Yes. We were just kicking off our last Fire Bootcamp sprint reviews, and and it didn't go well in the beginning while our service was down.
Yeah, I mean, all I can say is, I'm personally sorry for that, but it is, we're constantly striving to get better and better at it. It has over the last kind of 3 months. 3 months ago, back in November, it was really bad. We had a deployment, and lots of people were offline for extended periods. And so our team was working around the clock and all that sort of stuff, and not just the service delivery team, the entire, kind of Visual Studio Online team, but very sort of structured. Brian is driving, improvements to the platform and to the product to try and make these things, to make the service more resilient and things like that. One of the kind of special projects that I'm working on is what we call failure mode analysis, and so that's actually looking at our code paths, looking at our dependencies with other services, and analysing, okay, what protections do we have in place for those, and are we doing retries? Are we protected against this? Are we protected against this? And then doing fault injection, which is where we actually simulate failure and look at what the impact on the service is. And so that's an evolving kind of thing, because ultimately we have an SLA. It's not a real SLA yet, but soon it'll be financially backed, and we're tracking that and all that sort of stuff. So what I wanted to do first of all, I've kind of got 3 parts. The first part is probably just 10 minutes showing you what is visualstudio.com and Visual Studio Online, and hopefully I can show you some things that you didn't know about. Then I'm going to move into how we plan, or how we kind of plan to build the service, and then I'm going to talk about the running and how we actually kind of run the service and the operational systems we need to do that. So the demo, what I'm going to do here is just show you how quick and easy it is to create a new account in the service. Come along to visualstudio.com. I've kind of cheated here because I've already signed in. So I've created my MSA, my Microsoft account, or my Live ID, and I've signed in, and I've come to visualstudio.com. If I come along here and I say get started for free, I now get this screen where I get to choose, what name do I want to kind of call my own. Now, there's some interesting stories here. We had an incident, I don't know, about a month ago, where somebody came along and they created www.visualstudio.com. And well, the thing was, it doesn't work anymore, and it didn't work at the time, but what had happened was there was a period of about 3 weeks early last year where it did work. And so, that person has come along, they've gone www.visualstudio.com, they've hit create account, it's redirected them to www.visualstudio.com, and that's just taken them to our public website. It hasn't actually taken them to TFS because the DNS record, didn't exist. And so they had this account, but they had no way to access it. Anyway, that was like a little landmine, because about a month ago we started putting in the infrastructure required to allow us to move across multiple data centers. And what that actually meant is we created a DNS record for every single host in our system. Now, that job, it also wasn't checking, this kind of forbidden lists. So it came along, and it created a record for www.visualstudio.com and pointed it to TFS. So what happened to our public website? Went offline. So it's bad that these things happen, but we're able to find out what happened, regroup, put the DNS record back in, work out how this account got in there in the first place, and that sort of stuff. And so that was, there's a lot behind just having a text box there to say, hey, give us any name you want. The other thing that happens is we also do squat our own names and kind of reserve them. And so, the OneDrive announcement, so SkyDrive got renamed to OneDrive, I don't know, about a month ago. And I've gone in, I've gone, oh crap, we don't have a forbidden, we don't have that on our kind of blacklist. We better go put it in there. By the time that the announcement had come out and I've gone and checked, somebody's already squatted it. So in the end, it's not a big deal. Sorry?
Did it get reclaimed or it's theirs now?
It's theirs now. We kind of thought about it. It's like, yeah, they got there first. If the OneDrive team come along and they want to, reclaim that, we can have a discussion then. But it's kind of like, what's the value in us kind of claiming all these names? And there's probably not a lot.
Maybe they have a valid reason to call it that.
Yeah, that's quite possible as well, and that's why it's a discussion and things like that. So what I'm going to do is create, what do we call it? Sydney user group. The other thing that I'll check here is you can't start with a number. There you go. So it must start with a letter, can't contain letters, numbers and hyphens. And the reason that rule is there is because we're going to go and create a DNS record, and that isn't a valid DNS record. So we'll call it Grant Sydney User Group, say create account. Now what's happening in the background here is creating an account is to have an account, that's essentially a logical, interesting. This might be because the upgrade is still in progress and account creation could be still disabled. So I'm going to have to bomb out on this one. User group, that one's... Yeah, that's where I was going to go. All right. So, grant test dot. So, the reason... So what was going to happen in the background there is we were... That's very interesting. Grant test. There you go. What was going to happen in the background there is we were going to go and create a logical database and then create a collection and then put your user in that collection and have it ready for you to come in and connect to it and create a team project. Now, to do kind of all those steps, it actually takes like 10, 15 minutes for all those kind of processes to happen. Just like if you're running an on-premises TFS server and you go and create a new project collection, we have to still run all those steps up in the cloud. And so what we actually do is we have exactly the same. It's the same code base. So the same code base you get on premises TFS is the same code base that we run in the cloud. There's just a few if-defs for different things and that sort of stuff. But essentially what we do is we maintain a pool of pre-created accounts. So these are accounts that have been pre-created with like a GUID name. And when you sign up to the service, all we're really doing is renaming that account and assigning it to you. So that becomes a very kind of quick operation. That's a real shame that I can't do that. It's possible. It's also possible that I just don't remember the name. All right, so now I need to go to here. There we go. Now it's going to ask me to sign in. Another thing, have you guys heard of domains.live.com? Few people. Basically, I don't know who owns it, or who runs it, or who maintains it, or anything like that. But what you can do is you can take your own domain name that you own, kind of register it with this, and prove that you own it, and then you can create your own Microsoft accounts or your own live IDs, under that domain name. So it's actually pretty cool. What I'm going to do is use my live.com. Correct. It's not a domain registry. You've got to have your own domain and sort of come to it. And when you go to them, you've got to create a DNS record that they tell you to kind of verify that you actually own the domain and that sort of stuff. But what it does mean is that you can have Outlookcom and it can be webmail for your own domain. So it's great for families and things like that. You can sync your phone to it. It's just Outlook.com. So I quite like it. And it means because it's your own domain name, you have control of that domain. So if you want to move it elsewhere to, say, Office 365 in the future, you can do that. So what I've done now is I've signed into my account. Now, normally, I'm not getting the new user experience here because I've already kind of this is a pre-created account. But what I can do is come along and go to look at my projects and teams. Get to browse my server, and I've only got access to one project there. I'll go navigate. So all this traffic here, it's going back and forth between Chicago. We do a lot of caching and browser e-tags and content expires and things like that to make the experience kind of really sort of fast. But at the end of the day, it is going back to Chicago. Yep.
Do you want to explain to us what the story is with these early adopter accounts?
These early adopter accounts, yep. So you might see up the top here, it's got a little banner up here. Your account is an early adopter account. In 49 days, your account will revert to a standard account. So basically, if you signed up before, I forget when it was, basically when we announced it, that we were going to start charging, we kind of grandfathered in everybody that had an account as an early adopter. And so that kind of lets everybody know that at a certain time, we're going to shift to paid plans. There's going to be a free tier, which is like 5 users, and then a certain number of minutes of build and load testing. 60 minutes of build, there you go. 1,500 hours. Virtual core load testing, yep. And you do and don't get access to certain features, as part of that. And then the next level up is like you can pay per user, and then there's other offers whereby if you have an MSDN subscription, that'll get you, certain access to TFS and things like that. Interesting backstory on this early adopter account. Up until this morning, the early adoption expiry. You can tell I spend all day with Americans. Was it was going to end at like 2 a.m. Redmond time because everything's made in Redmond. But it turns out that's going to be too early or too late or something. So that part of the deployment today was they had to shift it by like 8 hours because when that expiration was put in there, it was put in Redmond time rather than like UTC or some sort of conversion like that. So although it still says 49 days, it's changed from like 48.2 days to 49 days. All right, I was going to come along here and click this link, which is open in Visual Studio. And what you'll notice here is it's given me a URL called vsweb://. So this is a little Windows protocol handler that when you have Visual Studio installed, it's a little bit of magic to kind of take links out of the web and open them correctly up in Visual Studio. And what you can see now, instead of me having to go, into Team Explorer and type in a server name and all that sort of stuff, it's just got all the information it needs. It's going to authenticate me inside Visual Studio, and I sign in there. The nice thing about Microsoft account, you can turn on 2-factor auth. So if you wanted to, you could have the Authenticator app on your phone. It'd ask you for a 6-digit kind of one-time password. You type that in, and then you'd be authenticated, and it would renew and things like that. So, all the benefits that you get of a Live ID or a Microsoft account is it's all there as well. All right. So now, I'm connected. I've got my project. I can come to Source Control Explorer. And it looks and works just like it would if you had your own sort of on-premises server. You can probably see what I've been testing, 50 meg test. Let's see if this actually works, or I'll go view, see how long it takes on Adam's connection. Maybe not. What I wanted to show you is something that we call load test, elastic load test. Is anybody using the Visual Studio Online or has used the Visual Studio Online load testing service? Yep, one person. So essentially what it is inside, oh there you go, Visual Studio is busy. Because I can come along here, I can go test, I can say a new test project, and it's a web performance and load test project. I'll say okay. It's going to go off, do everything it needs to, and then I click on web test. The first thing I want to do is actually go and record that test, or record the steps that make up this test. So I click add recording. Now before I do, I'm just going to close some windows down so we don't get some funny results. And close all tabs. All right, record. So IE starts up. It's got a little plugin for IE. And I have to start that again because I had it disabled. There we go. And you can see that it started recording. So the test that I'm going to do is I'm going to go off to bing.com. And I'm going to search for Visual Studio Online. You can see all the requests on the left-hand side. This is the autocomplete that it's kind of sending off. And then I'm going to go and click on visualstudio.com. And so once I've kind of captured those steps, I can hit stop. It brings them all into Visual Studio, and it goes through a process of detecting what they call dynamic parameters. And this is basically things like session keys and queries, and basically stuff that's changing every request, but actually doesn't matter. And then you get to kind of clean up this test, because maybe you don't actually want to test the autocomplete function. Maybe you just want to test the fact that the site returns a response in a certain amount of time. And I can go cancel there. And so there's navigating to the home page. There's all the autocomplete stuff. And you can see here under search, there's the query string, Visual Studio Online, with a few other sort of parameters and things like that. And then we went to the home page. All right. So our web test is just going to basically call 3 URLs, and then at the end, it's going to validate that basically we got to this last URL. I'll hit save. Now, if I was to hit this button here, run test, it would go and do that from my local machine. That's not actually what I want to do. I want to use the load test service in the cloud. But first of all, I need to create a load test. And a load test in Visual Studio is just, you go add new load test. And what you have to do is create kind of this load profile and then add a mix of tests to that load profile. So we go next. What do you want to do? Do you want to do constant load or step the load up? I'll do step the load up. That's the cool one. So basically what we're going to do is we're going to start simulating 10 users, and then every 10 seconds, or we'll make that every 5 seconds, we're going to add another 10 users to our load test. And basically we're looking to kind of break our web server here to see at what point, or can it cope with this sort of ever-increasing load. We'll go next. We want to add the test. There's my web test I recorded earlier. If I was doing this on premises, the load testing software includes a network emulation driver, and this is pretty cool. What it actually does is sits in your network driver stack and introduces jitter and delay and latency so that you can actually simulate your website running across these slow connections. I've used this myself as part of diagnosing issues on the service. For example, there's one issue at the moment whereby if you're on like a dial-up modem and you're using an older version of the TFS client, when you go to check in a file and upload that content, it runs for like 5 minutes and then the connection gets dropped. I'm like, that's actually pretty bad. And to validate my assumptions, I created a network load test that didn't actually do anything other than just slow my network connection down. Funny aside there, I also had a remote desktop connection to the server. It also slowed that down as well. So be careful where you do this. In the cloud, we can only do LAN. We can simulate different browsers. Now this isn't actually doing like Watan testing, it's not doing actual browser testing. It's simulating things like the number of concurrent connections that a browser will open to a specific site and things like that. We'll just leave it there. We'll go next. If you wanted to, if you have access to the servers that your load test is going to be actually hitting, you can add those servers in here and it'll pick up the performance counters from those. So it can analyze the response time from the cloud as well as the local kind of performance counters and things like that.
The Azure, if you're testing against an Azure site, it seems to be hard to find.
Yeah, if it's a, how do you hook an Azure, an Azure website if you're testing against an Azure website? Yep. Basically, you kind of have to set up the VPN connectivity to. Yeah, you kind of have to set up the VPN connectivity to make that machine part of your network to do this sort of stuff. So it's not there yet, but the other thing you can do is pull the perf counters in manually and add that kind of to your analysis at the end. But it's, it's okay. All right, we'll go finish. Now what I want to do, now that I've got a load test, is I want to go into test settings, and this is the only thing that you need to do, besides having enough credit and things like that, to run a load test from the cloud. Tick this box down here which says run tests using the old name, Team Foundation Service. You go next, and you go apply, next, finished. And then we can come in here, we can say run load test. So you can see up the top here, what it's done is it's gone and talked to our load testing service. It's acquiring resources, so we're allocating machines, on your behalf, or we're allocating machines out of our pool to run a load test for you. And on the right here, you can see this run will use 2,000 virtual user minutes. That's the stuff that you get billed by, and it's got a sample rate is less than the minimum, and who it was requested by, and how many calls you get, and all that sort of stuff. If we come along to graphs, we can actually see the load test in progress, and it'll show us the user load going up and the average response time and things like that. So the one caveat to all this is your website has to be externally accessible, as in our Azure load agents must be able to connect to the site that they're trying to test, and yeah, apart from that, everything just kind of works as if you were doing the test yourself. Does this look interesting to people? Cool. How many people load test their site, already using some, third-party tool or something like that? Yep. You use this? Cool. Of course you do. All right. So as we can see here, we've been running for 30 seconds. The user load has jumped from 20, to 30 to 35, and it's just kind of keeps going up. But the Bing response time, interesting. The page time has gone up to 50. Obviously, some sort of DOS protections kicked in, and they've started throttling us or doing something like that. But you get the idea. That's load testing in Visual Studio Online. Any questions on that? Cool. All right.
Can you select the number of machines you distribute across?
Yeah, you choose. The question was, can you select the number of machines you distribute across, as in the number of machines that you sort of generate load from, load agents? Yeah, you choose. I think it's like virtual users, and then there's a formula that works out how many machines are needed to generate that number of users. The other thing I want to show you is application insights. grandh.visualstudio.com. Now, oops, I'm going to do in private. I'll be honest, I'm not going to do it justice, but Application Insights is a preview kind of service that we announced towards the end of last year. But think of it as things that you do kind of with SCOM today, System Center Operations Manager, or things you might do kind of in an ad hoc way of collecting, traces and performance counters of your applications. But the whole idea of Application Insights is it brings it all into a dashboard and gives you insights into what your application is doing. All you have to do is install an agent on your web service. So, or an agent on your Windows Phone app or Windows 8 app and things like that. So we come along here, we go to Application Insights up the top here. The service is evolving. The UI, in my opinion, is not as good as it could be at the moment. But one of the things that I find quite useful is they have this feature called availability. And there's this service that used to be called Global Service Manager. And essentially it's a way of using a whole bunch of Microsoft servers on the Microsoft network to essentially ping your website and record the response time and the availability. So for example here, we can go new single URL test. We're going to go call it SSW. We're going to go mail.ssw. Oh, it's HPS, isn't it? mail.ssw.com.au/OA. And we're going to start checking it from all these different nodes around the world. So any ideas of what happens here? The other thing, they keep adding in nodes to this list, and it doesn't scroll properly, so you actually have to kind of click and select or get a bigger monitor and things like that. So we'll say every 5 minutes it should return, I'm guessing it's a 200, and will alert if, I don't recommend you say one location failed in 5 minutes, because you just, there's transient internet problems all the time. You're probably better off saying, look, 2 locations failed in, 10 minutes or something like that, unless you want, kind of, more noise and more more frequent sort of notifications. We'll go OK. And what that's going to go off and do is queue that test across our sort of our availability agents, all across the world, and eventually the data will start to show up in this dashboard. So you can see here it's just blank at the moment. We might come back to it later. Here's the one that I created for the Canberra user group on Monday, Action Bus website, and what you can see here is that from the Japan node between that time and that time, we can actually drill in here. We can see that it was failing from that node, but at the same time it was working from Brazil and Russia and Singapore and New Jersey. So just this one feature alone is something that I find quite useful for just monitoring my own websites and things like that. Yep.
I've got a question from someone online. Can you do a load test from different geo IP address locations,
Yep.
USA, Australia?
Yeah, the question was, can you do a load test, which is the thing we talked about before, from different geolocations? And the answer to that is no, not at the moment. I know it's something they're kind of working on, but I don't know when or where it kind of be available. At the moment, they all come from the same sort of. Sorry,
Chicago.
I think it's Chicago. Yeah. So this is one part of Application Insights. The other part is under Diagnostics. And essentially what you do is you install an agent on your web server if it's running IIS and your applications are running ASP.NET applications. A lot of the stuff just kind of works out of the box. So for example here, the other thing that you'll find is you have to click this little link up the top here and choose which website on your server that you actually want to monitor. And so what you can see here is this is one of the websites that I run. The exception rate over the last 24 hours is like nothing. So if we go to the last 7 days, we can see the exception rate is still nothing. Average response time, 63 milliseconds. But what's really interesting is we can drill into something like a perf event, or what I'm really looking for is an exception event. That's a bug. It went to.
When you write perfect code, isn't it? You can't do it.
That's right. I have that problem all the time. All right, so exception rate, no. Come to perf events. See, I did say that I couldn't do this justice, but essentially, okay. So here's a page that I have. I created watched work items. So this is a way for me to kind of create a list of work items that I care about and see them all kind of in a dashboard and kind of pull in kind of extra information. But what that means is I've got this ASP.NET page, and when it loads, it goes off and talks to TFS, loops through a bunch of work items, and then renders the page. And so at some point, that took 5 seconds to load, probably because TFS was a little bit slow at the time. I can click on that, bring up the event details, and it'll bring up the stack trace, the response time, information about the browser and the user and things like that. This is all information that I can get without me having to put stuff in my code. It's just an agent that hooks into the .NET profiling, the .NET debugging APIs to pull in this sort of information. I can also download the IntelliTrace log, so I can do historical debugging on this request. I can expand all. I can see here that it's going into page load, calling out get work items. It then goes off and makes a web request, and that's kind of where it's this guy here is where it's spending all its time. So this stuff is evolving. It's just in preview at the moment, but that's just kind of like a glimpse into Application Insights. Any questions? Oh, all right. Let's get on to the good stuff. Building a service. So first part is I'm going to talk about how we build a service. Second part, how we run a service. And so the first part about building a service is you kind of got to architect your teams. And in the past, the TFS team and other teams at Microsoft were they're basically the same as they are now, but essentially the teams are cross-discipline. So that means that we've got a PM, a program manager, we've got devs and testers, and they all kind of sit together and work together, and they're responsible for a particular feature or a particular area of the system. Generally, they're sort of 6 to 12 people, and they stay intact for sort of 12 to 18 months, and that's for team cohesion and things like that. But obviously, you can, if there's a need to load balance, they'll pull a resource out and put him on another team and things like like that. Another key thing there is they run their own backlog. So it's not like Brian is talking to the teams and saying, you must do this. I mean, he does do that sometimes, but ultimately it's up to the team to take that and prioritize that within their own backlog of all the requests and goals and aspirations that they have. The organization is a very kind of flat sort of structure. We have teams like the version control team, the work item tracking team. The team that I work on is called the service delivery team, which is kind of like an ops team, but we're not just guys sitting there waiting for alerts to happen. My title is service engineer, and so think of us as there's program manager, there's a software developer, software tester, there's now a service engineer, and so they're kind of responsible for the operational aspects of building and running a service. What we also have is this team that we call VSOLs, and they're a 24/7 vendor team, and they are there to, when the alerts come in, they're the people that look at it first of all, and they'll triage it, and if they need to, they'll start engaging people like myself, and then we'll start engaging, the kind of feature teams and things like that. In traditional IT, in a minute, in traditional IT, the guys who run the servers and the services are usually like a separate building, separate management chain, all that sort of stuff. In here, we've got one leadership team. So if something is not working properly, like upgrades aren't going well, we have one leadership team which can drive change, whether it be people, process, or sort of technology change. Question, Adam?
I have a couple of questions. What's VSOLs, and also the Agile project management, is that the Agile tools or the work item tracking?
So these names aren't exact, and they change. They don't change all the time, but they changed recently enough for me not to know what they are. But think of it as any feature that you sort of care about in TFS is owned by a feature team. It's not like it's just a group of features that kind of everybody has shared ownership. It's owned by a feature team. The team down the bottom here, VSOLs, is Visual Studio Online Live Site team, and so that's a vendor contract we have, and they are metriced on things like, okay, an alert comes in, did they acknowledge that alert within a certain SLA? Did they follow the steps correctly? Yes or no? And did they escalate within a certain kind of SLA and things like that? And their bonuses are based upon how well they perform that job. So they're really good at following instructions, and it helps us kind of scale the number of services that we operate without having to add full-time employees and people. There's not infinite copies of myself. Team rooms. So not only do we structure the teams as feature teams, about 12 months ago they did a full refit of Building 18 in Redmond, and converted, basically ripped out all the walls, left the shell there, and then they converted it to team rooms. And so a team room would be kind of the size of this room that we're in now, but the only people kind of sitting there is a feature team. So that's 6 to 12 people, I think it was. They also have their own private kind of sort of focus room, which has just got like a little table and a monitor, where they can have sort of one-on-one chats. And then they have their own meeting room where they can have conference calls, with their counterparts in North Carolina, or have their sprint planning and things like that. And so it's kind of good and bad things from my perspective about this. I mean, the old days was that everybody had their own office, or they shared an office, and that was great because everybody kind of got their own space. But there were some problems with that because people wouldn't talk to somebody, in the next office. They'd rather send them an email or something. And so by putting people physically in the same place forces them to hear, context about what other people are talking about, as well as, see them and talk to them on a sort of a daily basis. From my perspective, I went over there, July or something last year. And if I wanted to talk to people, I couldn't just sort of drop by their office. I had to go and first of all find out which team room they were in. Then I had to sort of open the door and sort of gingerly walk in and go, do you want to chat? And then we had to sort of, get up and walk away. Otherwise we were sort of disturbing everybody else. And so that's kind of a good thing, kind of a bad thing. But, they're doing it. It's an experiment, and we'll see how they go. I don't know whether density of the building or anything was a factor. I mean, yeah, you could probably say that they did increase it because instead of each person having a certain amount of space, But at the same time, if you look behind that green wall there, there's a kind of little walkway, and behind that wall there's a big, big TV setup and an Xbox, and that's kind of the Friday afternoon drinks or just kind of the informal sort of area. So, although everybody may not get their own dedicated space, the rest of that space has been reused for sort of other collaboration spaces. So planning. This is kind of what the timelines looked like before we sort of switched to building a service. There's this period that we call planning, which is where we go away for a few weeks or even months and come up with the vision and the high level goals and things like that. And then we'd have this milestone called milestone 1 and then a milestone called milestone 2. And essentially that was broken up by you have a few weeks or months or whatever of coding, and then an even longer time testing and stabilizing. And then that's when customers see the beta, and then repeat again, and then customers see the RTM. And so the problem with this is that the beta would go out, and customers would have a problem, or they'd have feedback, or something like that. Or often it'd take them a few weeks before they get it installed and have a chance to kind of really kick the tires. And then we actually get the feedback. We're in this last week or so of coding, and we don't have time to react to that feedback. And so that's why, as a customer, the old thing was, you've been asking for this feature, for 2 years. It actually has taken us 2 years to actually do it because we've already planned, up front what we're going to be doing for the next 2 years. But now we're on 3-week sprints, and so that was a massive change to go from 2-year cycles to doing everything that we used to do in 2 years. It's now done every 3 weeks. And so the first thing you'll notice here is there's a little dark blue sort of overlap at the end of each sprint. So that means that we're doing 3 weeks of coding, testing, validating, all that sort of stuff. And then the following week, we then deploy whatever was coded in that previous 3-week sprint. And that's why every 3 weeks we're doing a deployment, to the online service. So one of the sort of challenges with that is, okay, in the old kind of 2-year cycle, if you want to do massive kind of architectural change or something that kind of touched every bit of the system, you could plan for it, you could make that code change up here, and it's going to get tested and stabilized and deployed, and you've got a long time to kind of introduce those changes. When you get to this 3-week sprint, you don't have that luxury because you can't make these massive changes in 3 weeks. And if you did, everybody would probably kill you because you've basically stopped them from doing anything for 3 weeks. And so to do this sort of stuff, they introduce what they call feature flags. And feature flags are essentially, think of at runtime, we can turn a bit of code or a particular code path on or off with a database flag. And we can turn it on or off based on your account name, based on an IP address, based upon 10% of all traffic, or a number of other metrics. But it's a way of it allows the teams to write a bit of code, have it appear, have it get deployed, in the next deployment. But then they can build, an add-on to that in the following sprint, and they can kind of build up that functionality over time, and then they can turn it on, gradually, rather than having to turn it on for everybody, all at once. And so when you see us doing things like big keynote announcements, so like build, for example, we're not actually sitting there doing a deployment on the day of build, waiting for Brian to say, oh, and now we announce, click. It's actually just there's a flag in the database that gets set, so all the deployment, all the testing has happened, weeks before, and so a keynote launch is just really setting a flag in a database, and it's a really nice way to kind of do these deployments. Rolling upgrades. First one, upgrade must be an online operation. And so gone are the days where we can take your collection offline for, whether it's 1 minute, whether it's 30 minutes, whether it's 3 hours, just because we need to change some schemas or add some new features. Everything we do now has to be online, and so that pushes down into the teams. They have to think about, every time they add a new feature or make a change, they have to think about how they're going to get existing customers from their current version to the next version in an online way. The way that we kind of approach that is we split the changes into 3 parts. There's the database schema, there's the web services, or essentially the public kind of interface, or the API kind of interface, and then there's the website, which then leverages that interface, or it might be Visual Studio itself. And so what actually happens is in one sprint the team might make the schema changes required. The next sprint they'll come along and make the API changes, and those API changes will work with new schemas as well as old schemas, and so it's able to determine which schema the customer is on, so that it can write it in the correct location and sort of things like that. And then a following sprint will come along and add in the web interface to use those kind of new interfaces. Question?
Yeah, I have a question, and I think this is about the right time to ask. It's about, Brian said that he is going to allow people to download their entire database and restore it on-premise.
Yep.
And I believe that's coming very soon, because they're about to start charging.
Yep.
And I would like to ask your opinion on that, because my understanding is he's going to allow that to work at any time.
Did he say that?
No, well, I had asked team members, and I got the impression it will always work.
Okay.
So if that means it will always work, that means as I upgrade to, how there's a 3-week cycle, each team, as they deliver 3 weeks worth of functionality, they have to support that will be able to be backed up and restored here. So let's just say that they add column. Do you know where I'm going with this?
I don't know where you're going, but
Okay.
I'm with you so far.
Okay. As they, in my sprint, my 3-week sprint, I might decide I need an extra I need a schema change for this feature to work.
Yeah.
But I not only need a schema change, I need to work out how am I going to still allow the whatever we call
Down
it,
level.
the down level experience, so that people can restore it on premise at any time, which would mean that I have to cater for what's going to happen when the server on premise doesn't have those extra columns.
Yep.
And to me, that is the most monumental tax on innovation I can think about.
Yep.
And so my thinking would be that it would be easier on the developers if that feature only worked if you were stuck on old versions of the service and not newer ones that were on the 3-week cycle.
Yeah. So basically, what's happened is the last sort of 6 months, every time a feature team has added a new feature, not only have they had to write the upgrade steps, that gets them from sprint 1 to sprint 2, they've had to write the downgrade steps, which gets them from sprint 2 back to Visual Studio 2012 or 2013 update 1 or something like that. So the restriction will be that you'll only be able to go from you'll be able to go. See, this is all changing, and I don't know what the official line is, but there are restrictions about what version you can go from and what version you can go to, and that kind of algorithm is a function of basically, as new stuff gets introduced in the service, there's got to be stuff in the on-premises version to understand how to deal with that kind of new stuff, and that comes to customers in the form of an update. And so what I think the expectation is that you'll be able to go from a version of the service to define, to maybe the latest, or maybe the latest -1 of the on-premises version. It's not any version to any version. Because of the tax, like you suggested, of having to do that sort of stuff. Now, the reason where all this sort of comes from is Microsoft has an online services policy, which is every online service at Microsoft has to kind of meet this policy. Just like Office 365 or CRM Online, you have to have the ability to get your data into CRM, or get your data into Office 365 through the form of an import, as well as you need to be assured that you can get your data out of the service and runnable in some sort of form if you choose not to use the services. And so before we can start charging for the service, we have to give you the ability to get the data out and do something meaningful with it.
I understand the point about getting data out, and of course I want to get my data out so I'm not locked into you guys, but I don't believe that with Office Online, Office 365, I can't just grab that and turn it into my local SharePoint server.
You can, so I'm not sure about SharePoint. You can do a site export and you can do a site import. Office Online, so Outlook Online, you can do a mailbox export and a mailbox import.
And what about CRM?
I don't know about CRM. I'm guessing that they have something like that because they'd have to. They're charging for it.
Right.
That's what the policy, and that's what the Microsoft sort of cloud guarantee is. That we're not trying to lock you in. We're giving you, it's your data. You should be able to do something useful with it. But
look, it might
it's
work.
a tricky problem.
But I kind of, and it's to me, it feels so difficult as a developer that I wouldn't want to add. I wouldn't want to make schema changes ever because of this pain.
It's a tax.
And so I would, I think the only way long term it could work is if you check a box and say, I'll take the new stuff, but that means I can't get my stuff out.
Yeah, I don't think we're going that direction. Question?
I have heard a number of the other teams look at it from a slightly different point of view, where they're saying what we want to do is add all of these new features. We've been frustrated, we've had to wait for 2 years, so now we can lead with the cloud version and put a lot of the features in, and then aggregate all of those features and drop them in the on-prem version, so the on-prem becomes a second-class citizen to the cloud. So if you're going to start travelling in that direction, you just sort of need to lock off where you are and then aggregate forward.
That's exactly what we're doing. New stuff shows up in the service.
It ceases to be a tax. It starts to just be a legacy strategy to bring on-prem forward.
Oh yeah, but the point is that you can take the server as the service evolves. You've then got to wait for that on-prem version. Yeah. Alrighty. 3-week sprints. So the first week, second week, third week is all about, well, start of the first week is sprint planning. The end of the third week is, the done email. And then the end of the fourth week is the deployment, of that sprint. Now, some of the things, I'll get to that in a minute. Feedback before used to be, we might get some feedback at beta or just a bit after, and we might get some feedback, at RTM, but by then, it's way too late. With the sprints, we can get feedback every sprint. And the way that we communicate this is through the release notes. So if you haven't seen it, you can go to visualstudio.com/ I think it's like home and then news. And every release we do, there's kind of a summarized view of kind of what's in that release, as well as the on-premises version that feature is going to show up in, if it does show up in at all. The basics, 3-week sprints. We also, you can't just do everything on a sprint-by-sprint basis. You also need some sort of, longer-term vision. The way it works at the moment is, that's before. The way it works at the moment is we're kind of planning all the time, but we come up with a 6-month plan and an 18-month vision. And then once we've kind of executed on that 6-month plan, everything kind of shifts along, and then we have a new 6-month plan and a new 18-month, a revised, 6-month plan and 18-month vision. And so you can see the seasons here, fall and spring. That's the US kind of, fall and spring. And you might say, well, Seattle, it rains all the time, so is it just constantly, fall or something like that? Staying connected. So the other part of, sure, the teams are working in 3-week sprints, but how do we kind of aggregate that up or level it up to the management level and kind of make strategic decisions about, are we making enough progress, or are the teams balanced correctly and things like that. And the way that we do that is every 3 sprints we'll sit down and have what we call a feature chat, and that's each team comes in, they've got like 15 minutes to talk about 3 things. What's next on their backlog, so what's coming on the next 3 sprints. What are they going to? How are they doing with regards to debt? Whether that's architectural debt or technical debt or bug debt and things like that. And are they having any issues? Like, for example, have they been asked to do something which just shifts all their other priorities out and things like that? And so all that kind of gets aggregated up, and then management makes decisions about, no, we'll leave the teams as they are, or hang on, we need to shift our priorities, or we need to load balance, or something like that. There we go. Sprint mails. So these are, I know Adam does them here, or do you guys do them here? Sprint mails? Yeah. I don't find many customers that are actually doing, sprint emails. The other thing that we do is sprint videos. And sprint videos are, when you work in a distributed team, sprint videos are a way of, they serve 2 purposes. One purpose is, when you've got like 200 people working on the same project, getting them all together and sitting down for, a couple of hours, just to watch the end of the, to see what was accomplished that sprint, it's just completely infeasible. And so then, do you then do it every 6 months? And it gets an even longer meeting and things like that. So what we do is we have sprint videos, and that way people can consume them kind of on their own schedule and things like that. Now, it's great for me as a remote employee because I'm not in the hallways, I'm not having lunch with the teams, I don't really know what they're kind of working on, but I do make an effort to go through and read their sprint done emails and watch their videos to kind of see what's coming down the pipe. Here's the sprint planning mail. Essentially, it's got a little bit of a blurb. It's got some bullet points for goals, and then it's got the actual user stories of what they plan to achieve in the next 3 months, 3 weeks, 3 sprints. Next 3 weeks, i.e. a sprint. And then what they do at the end of the sprint is they do a reply all on that email, and then they add their results for the sprint, and they include a video. And so people will click through the video and watch it, and then people like Brian will then do a reply all and say, looks great, have you thought about this? Whereas generally people who want to know more, they'll reply directly to the team and say, hey, have you thought about this, and things like that. Yes?
And you'll be interested to see what the 5 big campers have developed.
Oh, really?
Because they've developed a solution around this.
Cool. I hear it's around sprint commitments or something like that.
That's right, Scrum commitments.
Scrum commitments, sorry, close. Have you registered sprint commitments?
We should.
Yeah, there you go. Because I internalised it as that. So what does this kind of cycle do for quality? So before, we get code complete. What do the bugs look like? Bugs just go up and up and up. We get into this test and stabilize, and there's just a massive effort to get the bug count down, and get to the point where we're comfortable shipping, the beta code. And then we go and write some more code, so the bug count goes up again. But we've got less time, and so it's a little bit of a smaller hump. And so really, that. I remember those periods, and they were pretty bad. People were going, we'd have like lockdown or going dark mode, and so for like a full week, everybody was sort of given permission to not be on email and just focus on getting the bug count done. And it was a huge kind of divisional effort to kind of bring that bug count down. Now that we're in 3-week sprints, we've got bug caps and different strategies, but basically that level of debt is sort of low across the whole sort of time period. How do we kind of manage it? We have something called bug cap, and a bug cap is a number of bugs that your team is allowed per developer. And so if you've got a team of 5 people and the bug cap is 5 bugs per per developer or per dev and test, then as soon as you have more than that number of bugs assigned to your team, it's kind of stop work, and you have to focus on fixing those bugs and get under the bug cap. Yep.
What do you define a bug? What is a bug and what is not a bug?
Pretty much everything is captured in the work item type called bug. Whether it's a doc suggestion, or whether it's a code defect, whether it's a test defect, whether it's a customer issue and things like that.
Is a spelling mistake a bug?
Yep.
Okay. Isn't there like some...
It's easy to fix. It might be fairly trivial, but it's also easy to fix. There's different priorities. P0, is like, you can't do anything until you fix that bug. And there's priority 1, which is, you've got to fix this sprint. And then there's priority 2, which is, at least by the end of next sprint.
What about a bug that is not very important at all?
It'd be like a P3, which means nobody's ever going to get to it. Yeah. And then set up an upgrade. In the past, everybody wrote a bunch of code. We test and stabilize, and at the end of 1 year, we do the beta release. And so, oh crap, we've got to get set up and upgrade working, and then to kind of continue work until RTM. Now, and so it was a huge effort to get set up and just upgrades working. Now, upgrade has to work every sprint because we're upgrading this online service, and upgrade kind of has to work for that to work. We also do security, localization, accessibility. We have sort of bars that we have to meet, across all of those or each of those. And instead of it being a big effort at the end of the cycle, it's now done, incrementally every sort of sprint. And then the other bit is feature flags. Essentially, feature flags are short-lived things. Once the feature flag is turned on for all customers, that feature flag is removed, and that's just kind of the normal code path. And then this bit here, stay on one branch, just kind of means that your feature flag shouldn't continue into the next release and things like that. At the end of kind of every sort of 6 months or something, where the aim is to have all the feature flags kind of removed and kind of move on to the next stage. Otherwise, what ends up happening is you build build up this debt of feature flags, you've got to test the path of, okay, this customer's got this one turned on and this one turned off, and then this one turned on, what happens? And then we turn this one off, what happens? And your test matrix just kind of explodes out. Does that make sense? Cool. Yep.
So you're working on a single branch.
Yes.
So your branching strategy is like just a branch for release?
Yeah, so the question was around branching strategy and how it works and things like that. Essentially, we have, Visual Studio Online is kind of a subset of Developer Division. So Developer Division ships Visual Studio, .NET, all that sort of stuff. TFS, or essentially what we call Visual Studio Cloud Services, has its own kind of sub-branch off main. Main is what kind of everybody's branched off, obviously. And then all our code is going into that sub-branch. Now, whenever we do, at the end of the 3-week sprint, we then do a merge from essentially our team branch, or our organization branch, if you like. We merge into our release branch, and then we merge down to our fix branch. And so that way, when we're doing our deployment, we've got a branch which represents a code that's kind of deployed in production. Now, we're not creating a new branch every time we go to production. We're just maintaining a single branch that is kind of aligned with production. Does that make sense?
Yeah, absolutely.
Cool. And that's because there's a tax that we have to pay every time we do a branch. We have to reconfigure the builds to point at that branch, and you don't want to be paying that tax every 3 weeks. All right, we're on to running a service. This has been my life for the last 6 to 8 months. Yep, question.
You mentioned that there is an overlap between when you are deploying and at the same time you are developing.
Yep.
So that's the first week of the next sprint.
Yep.
How do you handle the code check-ins from the dev and at the same time deploying the previous sprint?
Yeah. So
is it running on different code bases, different?
They're two different branches. We have our main branch, which is where the new sprint work is happening, and then we have our release branch, which is where this is the code that we're just about to deploy. So as we're doing the testing, pre-production testing of our deployment, any fixes that are needed to kind of fix that get checked into the release branch, spin a new build, deploy that. And then, as soon as that deployment's done, they then get merged back up into the main branch so that, the next sprint that comes along picks up those changes as well. Does that make sense?
Well, this way you would have one branch after every sprint, right?
Well, we're reusing the same branch for every sprint.
Yeah.
It's just that at the end of a sprint, that branch kind of gets locked down. Well, it doesn't really get locked down. We're just taking a copy of that and merging that down. So if your changes weren't in at that point, they're not going out. So. All right, running a service. We have this thing which we call operational intelligence. So this is essentially all the things that we need to be able to operate the service. And so if you are looking at building your own service or looking at running a service and things like that, one part is writing the code, the other part is running it. And to run a service up in Azure, for example, you have to do a lot of this kind of yourself. You have to think about, okay, it's running on this platform as a service, which is elastic. It scales, up and down. How are you going to? It's infeasible just to kind of say, oh well, I'll just remote desktop into the box and look at perfmon. That just doesn't work when you've got 100 machines to remote desktop into. How do you do things like attach a debugger? You can't just log onto a box and attach a debugger and step through the code, because there's a load balancer in front of you, and that load balancer, every request that comes in, it's going to a random one of those machines. So which machine do you attach a load balancer to? It's kind of you don't really know. Then there's other things like, okay, say something, there's kind of something that we call KPIs, but think of these as business metrics. So, we're operating service, we need to make money. How do we know whether people are enjoying using our service, whether they're exploring all the features of the service? How long does the project sign-up experience take? Things like that. So we have defined KPIs around kind of key user scenarios that we kind of track to see, what percentage of our users are going, through here, how long is it taking, could we make that shorter, and things like that. The other thing we have is activity logs. And so if you've looked at TFS on premises, there's a table called TBL command. And essentially every command that any user runs against a server, whether it's from Visual Studio or the web interface or the command line, it gets logged into this table. Up in the cloud, it's still logging to that table because it's the same code base. We're just pulling it all down into our own database so we can do aggregations across multiple customers and things like that. All right. The other, I'll talk about monitoring, perf counters, that sort of stuff. We're also following this, it comes from the lean startup, build, measure, learn. And here's an example of something that we kind of, we went through the process of build, measure, learn. It used to be called Team Foundation Service, and after you created an account, you got this home screen, and it had recent projects, nothing. You could hit browse all. It had this blue button called New Team Project, and then at one stage it didn't even have the red button, and this blue button was like grey. And so people, basically what happened is people got confused, or people didn't really know what the next step was. They'd come along, claim their name, and they get presented with kind of this screen. And so what we ended up doing is making a change. And so now when you go along to the service and you create your account, the first screen you get is this nice kind of pretty one. It's kind of sort of off green to sort of draw attention to it. And it asks you, what's your project name, description, what sort of source control do you want, and click here to create a project. Sorry?
It's nicer.
Yeah, I mean, it looks much nicer, but it's... what it resulted for us was like a 20% increase in the number of people that have accounts with projects on them. Because without a project, your Visual Studio account is essentially useless. And so we're constantly looking at these metrics and trying different things and looking at how we can sort of increase the usage of the service to help people be successful. So tracing. One of the things we needed to be able to do is, like I said, you can't just attach a debugger, you can't just remote desktop into the machine, you can't really do sort of console.writeline and have that kind of work. We started using ETW tracing, event tracing for Windows, and kind of the tracing framework you use is kind of irrelevant. The key thing that we did was scattered throughout the code, we have these unique IDs. Each sort of feature team is allocated a block of IDs that they get to kind of manage and use. But essentially these lines of code can be turned on and off at runtime, and the results of these kind of trace points all get aggregated down into a SQL database where we can run queries and aggregations and things like that. And so the way it works is if we have a problem in production, we can go and look at the code and go, right, I'd love to know what's happening, are we going through that code path, and how many users are going through there, and what are the parameter values or something like that. So we can go and execute a command to turn on this trace point, and then 5 minutes later we can start seeing the data from that trace point in our database. And so a lot of my day is actually spent just looking at these trace points and trying to make sense of why we're seeing a particular problem in production and things like that. Any questions on this?
Very similar to semantic logging access block.
Yeah, there's lots of different. So the question was, it's very similar to semantic logging access block, and yeah, there's lots of different ways to kind of do it. We built this 2 or 3 years ago, so that's kind of what we did at the time. Purview. Hands up if you have used Purview. All right, that's really bad. There was nobody. Hands up if you've used WinDBG. Okay, handful of people. Basically, Purview is built by a guy called Vance Morrison, and he's the architect for the .NET CLR. He spends sort of 3/4 of his time doing .NET performance investigations for either internal or external sort of Microsoft or external customers. Essentially, it's a profiler, and what that means is that you can run it in production, and there's basically no overhead. It's not going to freeze your process, so it can take a memory dump. And because it's a profiler, it can capture a whole lot of information to tell you a lot of things that are happening kind of in your application. Now, not only does it pull in all the .NET tracing events, it pulls in the Windows tracing events, so the ETW stuff that's kind of built into Windows, like disk, I/O accesses and things like that, and it brings it all together in a nice little view. The other thing that you can do with it is you can trigger it based upon a performance counter. And so you can actually set it up with what they call a circular buffer. So you might say, okay, give it a buffer of, I think the default is like 500 meg, and just sit there and just keep profiling with this, you only using sort of 500 meg worth of disk space. And then when this perf counter, say CPU, hits, above 40% or below 40%, or maybe a disk counter fires, or maybe your .NET garbage collector, kicks in or something like that, then capture a profile for 30 seconds before and 30 seconds after, and then take that file and send it to me. And so then you can take that file, you can analyze it offline and find out exactly what was happening, in the middle of the night on your server when you get this kind of spike in load or spike in CPU or something like that. I'd be capturing perfview traces probably twice a day, for weeks. It's that important to us, being able to run and kind of tune and monitor the service. You can, it's free. You can watch these tutorials and learn how to do it for yourself. It's very useful for .NET performance issues, but it's also useful for my machine is slow. What is it doing? You can profile all your processes and see which one's using the disk the most, or who's consuming CPU, and then you can drill down into those methods and kind of see which API, which process and which API and things like that. So I encourage you to watch, I think there's like 4 or 5 different tutorials. Watch it and have a look at it. Vance is very passionate about it, and I didn't know about it sort of 8 months ago, but now I kind of use it all the time. So have a look at that one. The other thing that we use it for is we're keeping track of CPU metrics between releases, and so we'll know that our baseline CPU, during our peak period is like, let's say it's 60%, and then we'll do a deployment and it goes up to like 65%. That difference of 5% is actually really important, because that could be the difference between us having to add a few more servers or not, to service the same number of customers. And so we'll actually go and investigate those 5% regressions, because a 5% regression, in one sprint becomes a 10% regression the next sprint, and as you add, kind of more things. So very useful. How do you do monitoring in the cloud? So Azure Cloud Services are essentially virtual machines running up in the cloud, and virtual machines, they're just running Windows, so they collect perf counters, but you can't really sort of log onto those machines and have a look at the perf counters, because these machines could be rebooting and re-imaging and recycling kind of at kind of random times. And so when you use Windows Azure Diagnostics, it actually installs a little agent inside your virtual machine alongside of your application. And you configure it to say, all right, of these 1,000 performance counters that exist in Windows, I care about these 10 performance counters. I want to collect them, I want to sample them on a 15-second interval, and then I want to upload them to storage on like a 5-minute interval. Then the other thing that we do is we use System Center Operations Manager. It has an Azure management pack, and essentially what that management pack does is just pulls these raw kind of perf counters into an on-premises database, where we can then run reporting services and dashboards and do everything that you would do. I did have an example. Yep, question?
Just on that, what do you use to clean all of the Azure Diagnostics out? Because I've found that it's really, if you blink and suddenly you've got 10 gigabytes of table space, they just continue to go nuts.
We don't.
So when you suck them out, you just...
So the SCOM, the Azure Management Pack does have an option in there to purge up to it purges like 30-day window and things like that. But what I found out is that we actually haven't turned that on, and so we've got all our raw performance counter metrics for like 3 years.
Yeah, because it's easy to purge the blob stuff, but the table takes forever.
Yeah, but at the end of the day, in fact, it's a good case study. There was a service at Microsoft that were ingesting so much data and writing it to table storage. Now, the thing about table storage is you pay for when you read the data, you pay for when you create the data, and you pay for if you go and delete the data. They're kind of 3 separate operations you have to pay for. For them, they did the math, and it was actually cheaper for them to leave the data in there and pay for the storage cost than it was to pay for the delete operations to delete those records. So there is a bit of math in there about how you kind of, whether it is worth deleting and things like that. Yeah, I mean, yeah.
There's also the cost of just, depending upon where your deletion agent runs, you wind up paying for egress data out of the one service to the other service to get rid of it.
Yeah, exactly. There's everything costs money. The other thing that we had to build into our system was these concepts of alerts and incidents and notifications. And so it starts off by an alert might be something. It's just a bit of something that when the developer's writing their feature in their code, they know a particular condition is going to be bad, and somebody should kind of find out about it. But what happens is those alerts fire, and there's an agent that kind of aggregates those alerts and determines whether this is one incident or whether these multiple alerts kind of also become one incident, and then it determines whether a notification needs to go out based upon that. And so we have this concept of stateful alerts, and so something might kind of be reporting healthy, it'll go into a warning state, then it might go to critical, back to warning, critical, back to healthy. That all kind of gets recorded as one incident with one or with a couple of notifications on it. This one here, it went from, straight away it went from healthy to critical, that's an incident, and then it went back to healthy, that's another email to say this condition has kind of resolved itself. But these are kind of the things that we've had to build to be able to kind of run the service. I was talking about dashboards, and yep, question down the bottom. You got a mic?
So just on the notifications, do they go out as app notifications or SMS or email or direct to applications?
Yeah, these notifications, these ones in particular, they get recorded in the database as a notification going out, as well as they get sent as emails to I remember I talked about that vSols team, the vendor team, and they're kind of the front door for our notifications. They then, I've got a slide here in two slides time, called a knowledge base or a troubleshooting guide. They then follow the steps in that, or that a troubleshooting guide matches an alert to say, okay, when you get this alert, you need to do these 3 things. In fact, I'll just show it to you. There you go, troubleshooting guide. So it says when you get this alert, you need to look at this, look at this, look at this, and if this says this or this says that or whatever, if everything's bad, then click this button and call somebody like myself. And so it is email. It's not great, but Microsoft kind of that's the way things have run in the past. I would love to not to rely on email, but that's kind of how it is. Does that kind of answer your question? Cool. If I go back to service status, dashboards. So what we have is we have a dashboard, and this is the dashboard that Brian would look at multiple times in a day, and the dashboard that kind of management and business people and those sort of people are looking at. And remember before I was talking about KPIs, the sort of the experiences, the customer experiences that we care about. This is an example of the Create Team Project scorecard. And so you can see here the blue line is, okay, how long is it taking at the 50th percentile? How long is it taking at the 99th percentile? And the 10th and things like that. And so, and the green line, I think that might be the current one or something like that. But you can see here that creating a team project at the 50th percentile is like 20 seconds, and we'll be looking at when we do a deployment, does that go up or down and things like that. And then on the right hand side here we've got a whole bunch of tiles which say basically the raw data behind that. You can see other ones here like project team homepage scorecard. So that's when you first go into your account, you get a list of the projects that you've got. We also track how long that takes because that's the first page people see after they log in. We also track availability, account users and sign-ups and all that sort of stuff. All right, support systems. To run a service, we needed to create an incident management system. LSRs and MSRs. An LSR is a live site review, so keeping the site running and just the operational kind of aspects of the site we call live site. And some people call it kind of site up, as in that's the number one priority and things like that. And so every week we have a meeting called an LSR, and in that meeting we review with management and the people involved the incidents that happened over the in the previous week. And so that's kind of like problem management. We're looking at, okay, why did this incident happen? What was the impact to customers? So this upgrade failure we had this morning, that'll definitely be the first thing we talk about next week. What was the mitigation we put in place? Did we deploy a new code fix? Did we, did we run a SQL query? Did we, just kind of wait it out? What was the root cause? So, we can't fix issues if we don't know what the root cause was, and we can't prevent them, from happening again unless we, understand the root cause as well. Problem management is essentially, okay, what are the things we should do to prevent this happening in the future, or what are the things that would enable us to respond faster and things like that. And we also track the timeline. So, when did the incident start? When was it detected? Because if there's a gap there between when it actually started and when we detected, that means we could probably do better at, our monitoring our detection mechanisms. When was it triaged? When was it escalated? When did we put communications out? Because there's no point us having an incident happening, and our customers start calling us if an hour goes by. That's too long. If we had put communications out, they may have not called us because they know that there's an issue happening and we're kind of working on it. This is what our service status page looks like. You can see up here that, in fact, let's see what it looks like at the moment. Down the bottom here, and there is, there you go, you go to support overview, there you go, Visual Studio Online status, it says we're updating the service, and that's because we're like, we've upgraded, we've put the binaries out there, but we're working our way through the collection databases to bring them up to the new schema, and so while the upgrade is sort of still in progress, we'll set it to yellow. And then what we also have is a blog, whereby one of Brian's things has always been he likes to share as much detail as is reasonable or as is possible about an issue, because what happens is if you let people know that there's an issue and if you give them some sort of insight into how the issue happened or why it happened, that kind of builds trust. And so as we have issues, we're letting people know, why we had them and what we've done to prevent them, because that's building trust, and hopefully we can all kind of learn as software developers, how to improve, in the future. So, for example, here we'll look at what was the issue you had this morning? It was issues on VS services. Service, and as we find more information, or as we put mitigations in place, we'll do an update to the blog post to say, look, there you go. The cause of the issue was a deadlock, which caused requests between TFS and our profile service to kind of get deadlocked, and we had to do a binary update to kind of resolve that deadlock. And then now we've said that kind of everything's fine. Do you have a question, Adam? Or yep.
Yeah. When a problem occurs and you keep checking the blog and you want to see if it's fixed, you see a message there that says it's been mitigated. Mm-hmm. Why don't you just say it's fixed?
Well, so mitigated doesn't necessarily mean fixed. Mitigated means that we've either turned off that bit of code or we've done something to kind of stop it happening, but it doesn't actually mean that we've deployed a fix to prevent it happening in the future and things like that.
Yeah, but in the title, it would be better to say fixed, and you can say, look, you could have that extra detail, because I noticed with the boot campers this morning, they're looking at that and then they see that they're not as, can we use it again?
Yeah.
What does mitigated mean? It's not a normal word to use.
So what I would say is this should be a source of truth. If this is yellow, then there's a possibility of problems. May or may not affect you. If it's green, then there should definitely not be a problem. It does take us time to add the blog posts and things like that, because we try to give there's a balance there between having enough detail to be useful versus getting it out sort of soon enough. But I'm looking for feedback here as well. So
okay, my feedback is to put a link on the blog to that other page.
To that other page, or just display that other page,
yes.
Right there. Yeah. The other thing is the blog is the blog is not a great way to do this sort of stuff. For example, if we go to live.
Can I take that feedback one place further?
Yeah, sure.
When I go to my home page,
yep,
and it tells me all this random how-to crap that I think is a bit unnecessary.
Yep.
That's where I'd like to see the service status, because I'm not going to go off somewhere else. I'm going to pull it up and go, oh, it's crap. Yep. Unless I can't see my page at all, in which case I still need that.
Yeah. Or in Visual Studio, when you can't connect to the server, should it show you the status there, or at least have a link to the status? Absolutely. Yep. What I'd love for us to have is something like this, because one of the problems we have is if you go to this server status page, Visual Studio Online is It's TFS, it's Elastic Load, it's App Insights, it's Hosted Build. There's like 5 different services with more sort of coming online. If any one of those services has a problem, this goes yellow. So we're kind of in this permanent state of yellow because just for the yeah, exactly. So this is evolving. At some point, we're going to have to evolve to something like this to say that, load test is having problems, but TFS is running fine, and TFS in this data center is running fine, but this one isn't. We're getting there. All right. So this is kind of the interface that I use to set the server status. When something's going wrong, we'll set a generic message just to kind of get the message out there. If we do, have more information, we can put it in there and update it, and then we've got the blog post and kind of things like that. Troubleshooting guides I showed you before. So these are just a custom work item type in TFS called a knowledge base item. It's basically got two HTML fields in it, and then we just we read from those and use that sort of stuff. All right, global on call. So one of the reasons Brian called me up and said, hey, do you want to work on the team? It wasn't really do you, it's like can you, was because they're running an online service, and they you don't want to have to wake your devs up in the middle of the night if you don't really have to. For example, if Windows Azure has got a known public platform issue, then there's really no point waking a dev up because he's just going to go, well, it's an Azure issue or something like that. And so what we ended up doing is staffing a team whereby we've got follow the sun across 5 different time zones. Now, it's my sort of responsibility to come up with, what are the shifts and things like that. So I'm constantly in timeanddate.com, looking at different times and working out, okay, this guy's got 4 hours and he's got 5, and then you kind of add it all up and you end up with like 26 hours. It's like, hang on, 26 hours doesn't fit into 24 hours. And then, what are our, 6 a.m. in Redmond is like, Monday 6 a.m. in Redmond is 11 p.m., on Monday in Canberra. So, my working day is down here, and it's a really bit, tricky to kind of work out. But essentially what we landed on is each engineer is on call for sort of their afternoon. And then every 10 weeks, they're on call for a weekend. And so that's a balance between having people on call more frequently versus the size of the team and all that sort of stuff. The thing that kind of really throws me out is daylight saving, because not only do you have 5 time zones, you've got 3 different daylight saving times or daylight saving kind of changeovers, because North America changes, March. And then 2 weeks later, European changes, and then like a week later, Australia changes. And then the other kind of bit in here is that India doesn't have daylight saving, but all their hours are half an hour off everybody else. And so there's a lot of, every time you kind of schedule a meeting or something like that, you've got to, basically there's no time where we can get together as a team and it's everybody's daytime. 2 people always kind of lose out. Now, how do we, the problem we had then is, okay, we've got this vendor team, they're really good at following instructions, but if there's an incident happening, we want to get somebody like, myself or whoever's kind of on call at the time, we want to get them engaged as quickly as possible. So we can't really give them this matrix and say, okay, if the time is this, then call this person, unless it's this day, then call this person. That just wasn't going to be, set them up for success. So we used a service called PagerDuty. Has anybody heard of PagerDuty? These guys are like one of the sort of web startups and that sort of stuff. They grew out of, a company needed to do it for themselves, and then it turned out that it was a viable product, and so now that's what they do. That's what they do as a business. And so what you get to do is set up these different schedules, and it's kind of like Photoshop layers. So if we go PagerDuty Follow the Sun, creating a Follow the Sun schedule. What you get to do is you get to set up different layers for your schedule, and they kind of get layered on top of each other. So this one here, oops, see if I can get my mouse aligned. What we're doing here is we're setting up a layer which says Greg and Ian are on a weekly rotation. So the first week is going to be Greg and the second week is going to be Ian. And then, Bhaskar and Tim are on, they're on the second team. And then what we get to do is we get to restrict, between the hours of 8 a.m. and 8 p.m, these guys are on call. And then from 8 p.m. to 8 a.m. the next day, these guys are on call. And so you get to kind of build up this schedule, define exactly how you want, and then they have an API where you can call into it and say, create an incident, or I want to notify whoever's on call. It then works out who's on call at that point in time, and it calls them, it SMSs them, it emails them, it sends them a push notification, and then within there you can do escalations, like send them a SMS, and if they don't acknowledge that SMS within 2 minutes, call their mobile phone. If they don't acknowledge on the mobile phone in 2 minutes, then call their home phone, and you kind of escalate it up. We use they actually call it, let's call it the boom 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 in your pants method, which is call them, call their home phone, call their work phone, call their mobile, send them an SMS and an email all at once. And so it's pretty hard to ignore it, when you have an incident assigned, or when you have an incident that's assigned to you. And whatever one you happen to be closest to, that's the one you kind of acknowledge on. We did have it set up to say, okay, the expectation is it's during your working hours, so you're actually at your desk. So email or your work phone is kind of probably the best one, and then call your mobile. But if somebody had stepped away to the toilet, or they're going to get lunch or something, that then resulted in a delay of like 6 minutes between when the issue was escalated and when that issue kind of got acknowledged, and then they've got to get back from lunch and all that sort of stuff. So what our vendor team have is they choose which service is currently impacted, and they hit engage. All they have to do is that. All they have to do is click that button. The responsibility of getting the right person contacted, that's kind of, we've sort of outsourced that to PagerDuty. And so the other thing you can do is you can have kind of multiple schedules sort of stacked up on each other. And so we say, all right, call the person who's supposed to be on call, right now. And if they don't respond within 5 minutes, then let the team know, because there might be somebody else in the team who's currently, at their desk. And also, a minute later, start calling, their manager, and 5 minutes later, call the sort of, it starts sort of calling up the tree. So it's actually worked out quite well, and for me, it's great to know that, because you might be at your computer, you might be trying to get work done, but if your phone starts going crazy, you know that you've got to stop what you're doing and sort of, jump on the live site issue. That's kind of the bulk of what I had. What I do have is some stocking fillers. Has anybody heard of application request routing? No? It's very cool. It's been around for a number of years. It's called R, and essentially it's a module. It's like mod rewrite in the Apache world, but essentially it's a module for IIS that lets you do software load balancing, if you like. So IIS accepts your request. It then goes into this module. This module can then look at that request and make decisions about what to do with it. And that decision might be, okay, route it to this farm over here, or route it to this server over here. And the thing, we actually use it in the service, and that's something that I'm pretty proud of, is we use it for our multi-instance. So we go digwebinterface.com. So for example, if you sign up to the service today, you get some random name .visualstudio.com, and where that resolves to is this IP address here, which is actually the IP address of our Chicago instance. And so the way that that's kind of set up is it's just a DNS wildcard record, and so those both kind of resolve to the same place. Oops. Now, once you come along and sign up to the service, we actually go off and create a DNS record that instead of relying on the wildcard record, I've now got a DNS record that points to this this first kind of TFS instance, which turns out to be the same IP address. Now, what happens if you want to sign somebody up onto the second TFS instance? That's not going to be that IP address, and that wildcard IP address is not going to point to the second instance, it's going to point to the first instance. And so when the customer signs up, there's going to be this gap in time between when that DNS kind of starts resolving for them to point them at the second instance, and when that thing kind of starts resolving. And so that request is going to end up at our first instance, and that first instance is going to go, well, hang on, your account isn't here, it's over on this kind of second instance. And so what we do there is we're actually using application request routing to accept the request on that first instance, look at the host header and go, I know about you, we just created you over on this other instance, and it does a reverse proxy over to that other instance. So there's a slight kind of delay in latency and things like that, but the customer experience is identical, whether they're regardless of their kind of DNS sort of configuration. So if we have a look at this. These are two accounts. One is actually on our first instance and the other is on our second instance. And so you can see they're two different DNS records that point to two different DNS servers, two different instances of TFS. And so as we add more deployments of TFS around the world, we now have a way to preserve that customer experience without relying on DNS resolution and kind of things like that. And ARR essentially allows us to do that. Has anybody heard of reference sources search? No? Reference sources is essentially the .NET framework. The source code is essentially public. And what reference source is it's now using this new search engine, or new, I guess it's a search engine or indexing or something like that. Adam, what's your favorite .NET function class library?
Sleep.
Sleep. So thread.sleep. There you go, method sleep. System.threading.thread.sleep, here's how it's implemented. Copyright Microsoft, there you go, sleep. Takes a time span timeout. It'll throw a argument, out of range exception, all that sort of stuff. Are you interested in who in the framework calls sleep? So we now click on sleep, and we can see in MSMQ receive helper, it'll call thread.sleep for that period. And what's this? Back off timeout helper. It'll call thread.sleep, with drift and all that sort of stuff. So really cool way to kind of understand, what's in the framework and how things are kind of, referring to each other and that sort of stuff.
How long has that been around?
So the reference sources have been around for like 3 or 4 years, but this kind of full text search kind of index, that's only been around like a couple of weeks. The other thing is it's built on Roslyn, which is the new managed compiler sort of stuff. And so it's actually a semantic model of the .NET framework. So that's how it's so quick to work out who's calling who and all that sort of stuff. 88 acres, has anybody heard of this? No? I find this stuff just fascinating. 88 acres is essentially the size of the Microsoft campus, but essentially what this site is about and the story is about is think about your big office buildings and the building management systems to run the air conditioning and the heating and all that sort of stuff. They're kind of set up for failure because you might have a sensor that senses whether the damper is open or closed, and it'll say, yep, the damper's open. But then the temperature sensor will be, and that's supposed to kind of cool the room down. But the temperature sensor in that room will sense that the room is getting hotter and hotter and things like that. But then, the sensor's already, the damper's already open, so it's like, well, I don't know what to do. And it turns out that the damper being open is actually a faulty kind of sensor, and so it ends up, the room is actually getting hotter and hotter and things like that. Anyway, basically Microsoft has got a whole bunch of different buildings, and they all run kind of different building management systems, and they spend a whole lot of time, or they used to spend a whole lot of time diagnosing faults in air conditioning and heating and all that sort of stuff. So somebody would be at their desk, some program, and he's going, oh man, it's too cold in here. So he'd log a ticket. Somebody would come around, they'd start doing readings throughout the building and try and determine, where the problem was. Now what they've done is hooked all that up to sensors just all through the systems, and they're basically doing analytics across it. And so now when there's a fault condition that happens anywhere in any building on campus, they're notified about it straight away, and they can actually prioritize it based upon the cost of not fixing that issue. And so if there's one air conditioning unit that's going bad in that actually covers a large area, that might be $1 million a year if that wasn't fixed, because we'd be overheating it and things like that. But by fixing that, they can get rid of that cost and things like that. So lots of computations and lots of data. It's all built in Azure and things like that. And universities and other big companies are talking to us to say, hey, can we share your integrations and your data and things like that. So that's my last little sort of stocking filler. Any questions on any questions on what we've covered tonight? No? Was it useful? Cool. The last thing, the takeaway that I'll leave you with is this this research paper called On Designing and Deploying Internet Scale Services. It's a couple of years old now, and it's written by a guy called James Hamilton. He was at Microsoft for like 10, 15 years, and now he's over at Amazon designing their cloud services and things like that. But in there's fascinating tidbits on how to build and run a reliable service. The takeaway from here for me was if operations are called in the middle of the night, the most likely outcome is turning the monitor off or some sort of mitigation. If a developer is called in the middle of the night, the most likely outcome is the problem actually gets fixed, because operations can't really fix the problems. It's the developers who wrote the code that can kind of fix the problems. And so, if you're interested, have a read through there. I read it 3 or 4 years ago when I started in this team, and it's absolutely fascinating. So, thank you.
Okay, so thank you very much, Grant. That was an awesome presentation, and we're very lucky to have it. He's a little too humble. He hasn't told us that he's built a patent. Do you want to tell us about the patent, Grant?
Alrighty. So that load balancing stuff that I talked about was, I went and spoke to a few different people. And they're like, "Oh, that's a really cool idea. Have you got a patent on that?" And I'm like, "No." And they're like, well, you should." And so if you go off to Google.com. Now the thing about Microsoft is every sort of 6 months, 12 months, they'll go around and talk to the teams and say, "Are you building anything that you think is nobody else is doing and you think is worthy of protecting that property," and things like that. And so I have no idea why that's not working. But if you do a search on Google Patent Search, it's called efficient implementation of user-provided DNS names, or something like that is the name of it. There's some fancy diagrams in there that show the load balancer and DNS records and things like that. So, I mean, the other thing that, I don't know whether you knew it, but it was designed at an airport, at Seattle Airport, waiting for Craig Harry to get a flight to go home. So one thing that not a lot of people know is that TFS was started in Craig Harry's front room. And because Craig is obviously Brian's brother, they built Visual Source Safe before it was kind of...
we don't mention that.
Oh, we don't mention it?
No,
it's banned here.
Yeah.
They built, they were members of One Tree Software that built Visual Source Safe, and then eventually they wanted to go back and do something new, and that was TFS. And so Craig essentially wrote a lot of the version control code for the first version of TFS. And so Craig and I kind of did a lot of work optimizing version control and things like that. But him and I kind of worked on the problem, and that's what we came up with.
Awesome. And so since he has a patent, he's rich and he'll be buying us pizzas tonight.
No, Microsoft has a patent.
All right, so with that, thanks, Grant. And if you're keen, head over to the Oaks and we'll be having pizzas. Thanks very much.
All right, see you guys.
Did you get all that? We'll take the SSW TV quiz and test your knowledge now.